Well, hello. And what we're going to do is start with the equation of a circle. So you learn this in geometry, that the equation of a circle has to have a center point and a radius in order for it to be a circle. And the radius is the distance from the center point to the circumference. So when we're looking at the unit circle specifically, we're looking at our XY axis. We already talked about how this is 1 unit out, 1 unit up, 1 unit out, and 1 unit down. And that when we create the circle, all of the points that live on the circumference of the circle are part of the unit circle. And our center point is going to be 0, 0. And our radius is 1 unit. That's what a unit circle is. Now, what happens is that no matter where you are on this circle, your radius is the same. So if I want to start here at the center and go out to the circumference this way, that's 1. If I want to go out this way, it's 1. If I want to make it real close to -1, it's still 1. That radius is always going to be 1. The center point is always going to be 0, 0. But what changes are the coordinates inside this circle. Okay, so the equation for the unit circle is x squared plus y squared equals r squared, where r is your radius. X squared plus y squared represent the center point at 0, 0. And r is the radius, so this is the radius squared. So this is something that you should have learned in geometry when you did geometry with circles. What we're going to do is we're going to develop what the sine, cosine, and tangent is based on this fact. And what we're going to do is use the equation of the circle to help us. Things to keep in mind are that when we are looking at a coordinate, I'm going to just plot one right here. And what I'm going to do is I'm going to create a right triangle here. So my radius is from my center point to my circumference. So this is my radius. And the distance from my center point to where my right angle is x distance, because it's on the x axis. So this would be x distance. And this represents the height, which would be the y distance, because it's going from the x-axis up. This represents y. So this represents a right triangle where we could do trig. Now the theta itself, let me see if I can draw it in there, is always anchored to the origin. So our theta will always be located here. So as we're drawing the unit circle, and here's our theta, we can start to see the relationship between x, y, and r for our right triangle. So what I want to do is I want to take this pink triangle that I made in the unit circle, and I'm going to blow it up right here. I'm going to zoom in just to the pink part so I can show you what I want to show you, and then I'll show you how it's attached to the unit circle and put it back together. So let's just zoom in on this piece right here, this guy right here. So I'm taking this in context right here. Here's my right angle. This is my y. This is my x. This is my r. And theta is here. So everything looks exactly the same as in the unit circle. This again just represents x distance. This represents y distance. This is the radius. And one other thing that I forgot to mention, although I don't know if it needs mentioning, is that this coordinate up here on the unit circle is x distance comma y distance. So this is going to be a coordinate they give you, x comma y. Okay? And so you would plot it by going x this way, y this way, and boom, there goes your point. That's what this coordinate means. So, but right now, this is the same diagram as this. Now, when we take a look at the sine function, we're going to look at sine first. Sine theta is always opposite over hypotenuse. So if I'm looking at this from the perspective of right triangle trig, from where my theta is, the opposite is here, the adjacent between the angles, and my hypotenuse is up here, which means that the sine of theta in this diagram and in the unit circle diagram is going to be y over r. That's sine. Sine theta is y over r. When we take a look at the cosine of theta, that's the adjacent over the hypotenuse. Our adjacent side is x over r. And our last one is, of course, tangent. I'll do him over here. That's opposite over adjacent. That's equal to y over x. Now you want to make sure that when you're taking notes that you literally have these three down. These are very important ratios for us for the unit circle, and this is going to make life so much easier when we do our math. Okay, now I'll be back on the next slide to take this a little bit further, but make sure you have this before you move on.